For question 4cii, they've given us an expression, an equation of sec squared x equals to 4 over 3 in the interval of 0 to 2 pi. We look at this and we know sec squared is no good for us, so we figure out an identity. Identity for this is sec squared x equals to 1 over cos squared x. That's good enough for us. 1 over cos squared x equals to 4 over 3. Rearrange this to give you cos squared x equals to 3 over 4. Now to get cos x on its own, which is what we want, that would be plus or minus of root 3 over 4. Plus or minus is crucial. We'll solve these separately. Or we can actually simplify this further. Cos x equals to plus or minus root 3 over 2. That's because root 4 can be simplified to 2. Now we have this. First we can solve for cos x equals to root 3 over 2, the positive version, and cos x equals to the negative version. Let's deal with the positive version first. Using our calculator, we can use the inverse to find x, and that would be pi over 6. So x equals to pi over 6. With our class diagram, pi over 6 corresponds to this value, pi over 6. And since we're dealing with the positive value of cos x, the regions we would be wanting is this cos section and the all section. We already have the all section, which is pi over 6. But now we want this section too, for the cos section. And to do that, that would be 2 pi minus pi over 6. And 2 pi minus pi over 6 would be 11 over 6 pi. And that would be it for our interval, because we're dealing up till 2 pi, which is all around. For this, we want the negative values, and the negative values would be this one and this one. These are the only places where cos x can be negative. Your calculator value will still be the same. It will give you pi over 6. Pi over 6. And to work out these two, you would do 180, or pi minus pi over 6, which is 5 over 6 pi, and pi plus pi over 6, which is 7 over 6 pi. And these would be your answers. Another way you could get to your answers is by drawing out a cosine graph. This is your region they want, 0 to 2 pi. So this is all we're going to use. They cross at 90 and 270. They want they want root 3 over 2 or minus root 3 over 2. So we'll say root 3 over 2 is here. And minus root 3 over 2 is here. We should change this to our pi values actually. So we have pi over here and pi over 2, 90 degrees, and 3 pi over 2, 270. Our first value for root 3 over 2, we go along, and that's given us pi over 6. Now we would go along again, and that's given us, the way we would find what that gives us is, from the moment this crosses a line over here, figure out the difference between these two. So the difference between these two, and then you just find the same difference over here. So pi over 2 minus pi over 6, pi over 2 minus pi over 6 equals to a third pi. So you just do 3 pi over 2 plus pi over 3, which would give you 11 over 6 pi. So this would be 11 over 6 pi. And for our negative region, now to find the negative value, since we found the positive root 3 over 2, we can do the same for the negative. We'd go along, and we'd go up to wherever point meets the curve. What we need to recognize in this is that whatever distance, because this graph is symmetrical, obviously I haven't drawn it to scale, but because this graph is symmetrical, the distance over here is going to be the distance, same distance as over here. The distance we know between pi over 6 and pi over 2 is a third, so you just add a third to pi over 2, and that would give you 5 over 6 pi. And the difference between these two again is a third, so to go from there to there you would minus a third, so 3 over 2 pi minus a third gives you 7 over 6 pi. And those would be your values for when cos x is minus root 3 over 2. So that's that. You can either use the class diagram, or you can draw out the graph and work it out using this.